Alright, question 1. In circle O, the central angle, angle AOB, and an inscribed angle, angle APB, intercept arc AB. Grace constructs diameter PQ to show two triangles in circle O. She then writes a two-column proof to show that the measure of angle APB is equal to 1/2 the measure of the arc AB. She's missing a few steps. Read her proof carefully and then answer the question. So with proofs, I like to duplicate the tab and pull them side by side. This is so that I can scan through the lesson and find that didn't link like I wanted it to. Okay, well, scan through the lesson so that we could find an image that matches this one. Let's see if it'll load it. Saying right now there was a problem. Okay, give it a minute. I'm just going to go show all since I just want to be able to scan and look for a diagram similar to this with a proof. And the proof is to show that the angle APB, right here, angle APB, or an inscribed angle, is 1/2 the measure of the arc AB right here. So I'm looking for this, and I'm noticing that this is looking similar. This point kind of looks more similar to it. And then we passed it. Okay, so there's 3 cases. So I'm noticing that this is this case. Hey, that is a good website to have. Okay. Sorry, side note. So anyways, I'm noticing it lines up with this case, that there's the diameter through it. So, says, I'm not sure how much help this will be through here because this one is referring back to the case 1 of the inscribed angle theorem. So let's jump over here and see if we can use some context clues to answer this question. So I'm noticing that we have measure of angle 6 plus measure of angle 1 is equal to the measure of angle 2. So the measure of angle 6 plus the measure of angle 1 right here is equal to the measure of angle 2. Okay, this is referring to this triangle right here, and there's a property in triangles where two angles, so 6 and 1, will be equal to the sum of an external angle. Like if that line, yeah, so just so we can see that line all the way. So 6 and 1 are equal to the angle 2. That is a theorem from, I'm not sure if it was at the beginning of this course or if it was in Geometry A, but it's called the exterior angles theorem. So I will just give that one to you. So blank 1 is exterior angle theorem. That's why this list of postulates comes in handy if you want to just scan through all of them. Right here, well, let's see if we can see exterior angles. So right here, triangle exterior angle theorem. Again, we had those 2 opposite angles, and here's the exterior angle. So this is the equal to these 2 added together. So that's what that is. Blank 2. Let's see if we can see what the measure of angle 6 is equal to 1/2 the measure of angle 2. So the measure of angle 6, again, I'm just trying to outline this so that we can more clearly see or have it more clearly defined. So angle 6 is right here. It's saying it's equal to 1/2 of the angle of 2. Let's see what happened before that. I'm saying that 2 times the measure of angle 6 is equal to the measure of angle 2. Okay, so context clue here, I'm noticing that there was a 2 here and now there is not, and that this was just measure of angle 2, and right now that this is 1/2. So they had to divide by 2 to have that reduced down to 1. So multiplying by 1/2 is the same thing as dividing by 2. So I would say that that is the division property because they divided by 2. So I've blank 2, I'm looking for division property of equality. And for the last one, measure of angle 6 plus measure of angle 5 is equal to the measure of angle APB. I am going to look at the statement above to see if I have any context clues. I'm noticing that the angle APB is made up of angle 6 and angle 5 right there. So here's angle 6 and here's angle 5. Together they create angle APB. So that would be angle addition because you have 2 angles being added together to equal the total angle, which is APB. So that would be angle addition postulate.